Hello there! I'm your technical trainer for this journey into the fascinating world of large language models, LLMs. We're going to break down how these amazing systems work, step by simple step. No need to worry about complex jargon. We'll keep it friendly and easy to understand. Our first stop is Module 1, the foundation, from words to vectors. This module is where we lay the essential groundwork. Think of it like learning the alphabet before you can read a novel. It's absolutely crucial.
From words to vectors. This module is all about answering a fundamental question. How does a computer actually read and understand human language? Computers are great with numbers, but words are messy. We'll discover the techniques that transform raw text into a format that a machine can process and learn from. This concept of transforming words into numbers is what makes LLMs possible. We're kicking off our deep dive into LLMs, and we start at the very beginning, tokenization. Think of it this way. When you build something big, whether it's a house or a complex essay, you rely on building blocks. For us humans, the main building blocks of language are words. We read and write words. But for a large language model, the building block is a token. An LLM cannot process the letters C-A-T. It processes a token that represents cat, or even part of a word like ca. So, what exactly is a token? A token is a small chunk of text that the model has been trained to recognize and assign a unique number to. They are the language units the machine actually uses. Here's the simplest analogy. Think of tokens as Lego bricks. You can build anything with Legos, from a simple wall to a massive starship. Your sentences are the complex structure. Your tokens are the individual Lego bricks used to build it. Crucially, tokens are often subwords, not just whole words. For example, human word, unbelievable, LLM tokens, un-believe-able. Similarly, running becomes run-ning, and dogs becomes dogs. Why the weird splits? Because by breaking words down into common prefixes and suffixes, un, ing, ation, the model can understand and generate millions of words, even if it hasn't seen the exact combination before. It's smarter and more efficient than memorizing every single word in the world. What is the vocabulary? If tokens are the Lego bricks, then the vocabulary is the entire box of unique Lego bricks the model owns. The vocabulary is the fixed, complete set of every single unique token the LLM knows and has assigned a number to. When a model is created, its tokenizer algorithm decides what those 50,000 or 100,000 unique tokens will be. Once the training is done, that box is closed. If you give the model a word it has never seen before, it doesn't panic. It just breaks that new word down into the closest tokens, Lego bricks, it does have in its vocabulary box. So the vocabulary determines the limit of the model's understanding at the most basic level. Why do we use tokens? This tokenization process isn't just an interesting technical detail. It's fundamental to the performance and cost of LLMs. There are 3 big reasons we use them. 1. Efficiency. It's much faster for a computer to process a sequence of 130 tokens than to process 500 individual characters. It makes the model train quicker and run faster. 2. Flexibility, the OOV problem. This is the out-of-vocabulary problem. If the model only used whole words, like an older AI, a single typo or a new slang word would break it. By using subwords, it can build flexibility. It can always find a way to represent a new word using its known subword tokens. 3. Cost. If you use LLM services through an API, like with a chatbot or ACK, you are billed per token. Knowing this helps you write shorter, more efficient prompts and keep costs down. A good rule of thumb for English is 1 token equals 4 characters or equals 3/4 of a word.